Hello friends, welcome back. So myself Vikas Shakya. We are going to discuss today about the pending things that we discussed in the last video related to the pipeline. So in this video, we are going to discuss about the accuracy score classification report and the confusion matrix. So I hope you must have seen the last video. If you have not seen that last video, you can go and you can read that. You can watch that. And then today we are going to see what is the accuracy score, what is the classification report, and what is the confusion matrix, and what is their significance. Okay. So let me show you this one, like what is accuracy score? So there are three things: accuracy score, classification report, and confusion matrix. Why we use them? We use them to find out how effective is our model to predict the things. So we are going to check the effectiveness, right? How much effective our model is. So first of all, we are going to discuss about the accuracy score. What is the accuracy score? Accuracy score is a metric. It's a metric used to evaluate the performance of the sentiment analysis tool. The test set data is considered to evaluate the accuracy. Whatever data you have, the test set data, that is used to that is considered to evaluate the accuracy of your model. The generated results are compared with the actual results as recorded in test set data. You must have something in the test data. In the test data as well, you have the final value. You have the value which you need to predict basically. But the thing is that you already have that value as well. And when you are testing your model, then you just want to see how close the predicted value is with your value, whatever available in the test data, right? That is what you do. So test data is nothing, but it's the part of your data that has been provided to you. So the entire data which is provided to you for the training, that is divided into two parts. One is known as the training data and the other one is known as the test data. So you compare it in the test data. Okay. So you compare it with the test data, whatever you have with the test data. So what is the test data accuracy score definition? So accuracy is nothing, but this is the formula. True positive plus true negative divided by true positive plus true negative plus false positive plus false negative. I hope you are understanding about the true positive and true negatives. True positive means where the result has been, positive, and true negative means where the result is negative with the negative sentiment. And then what are actually true positive, what are actually true negative, and then what are false positive and false negative. There may be few, results where something has been shown positive, but it is not positive. There could be few things where the result is negative, but the thing is that they might not be exactly negative, right? So they are false negative. So you add true positive and true negative, and then you divide it with the true positive, true negative, false positive, and false negative, right? So here you can see, like, you can see that the details are given here. True positive means correctly classified positive sentiment instances. True negative means correctly classified negative sentiment instances. False positive means incorrectly classified positive sentiment instances. And false negative means incorrectly classified negative sentiment instances. So I hope the things are clear to you now. Now you know the formula and you can understand it. Now, what is the interpretation here? So the interpretation is here, like accuracy score. It is from 0 to 1, right? It's like just like the probability value from 0 to 1. A higher accuracy score indicates better model performance, right? As much value you get towards 1, between 0 to 1, if you have the higher value like 0.90 or 0.95, then it means that your model is performing better. It's having a better performance model, right? So 1 is perfectly accurate, right? All instances correctly classified. If it is something where 0.9 to 0.99 accuracy is there, then in that case it is excellently accurate, right? It means like very few errors are there. Then it comes like 0.8 to 0.89, like it's a good accuracy, but there are some errors, but mostly of them are correct, right? 0.7 to 0.79 means fairly accuracy. It is fair, right? Significant errors are there. You need to, modify your model. You need to train your model more. You may need to train your model with some more data, right? Then it comes 0 to 0.69. It is very poorly performed. It has very poorly performed, right? Many errors are there. In this case, you must need to consider the retrain your model with some new data or correctly choose the transformer models. Maybe that the model that you have chosen for transforming the data, that is not correct. That transformer is not correct. So maybe you need to use some other transformer, right? But whatever transformer we have used for the sentiment analysis, they are sufficient for us to, just go through it and get the correct results. Okay, so here is the example output. So you can see like accuracy score. This is taken from the code itself. So what are the limitations now? Limitations are like accuracy score has limitations. What are those limitations? So one is imbalanced data sets. Accuracy can be misleading if one class dominates. Maybe that the data has been classified. So there are different class of data, right? There is different class of data, right? So each class has different meaning, right? Each class has different kind of data. Maybe one class is dominating in your entire data set, which you are using for the training and the testing purposes. So this may be that some particular class is more dominating there, right? So in that case, it may lead to errors, right? It may lead to less accurate results, right? Then comes the class distribution. Maybe the class distribution has not been done properly. Suppose uh, you had 50% of 60% of the data or 70% of data for one class, and for the other class you had around 40% of data. In that case, the distribution should be equal. The model should have the your code or your transformer model should have taken the data in such a way that the proportion of both the data, both the classes should be equal, nearly equal. In that case, the class distribution will be correct, and in that case, accuracy will be more, right? But if it cannot be done, it cannot be predicted whether the distribution has been done properly or not, right? So now let us come to the classification report. The second one is classification report. So classification report provides a comprehensive summary of your model's performance on each class. There may be different class of data, right? Class means you are classifying the data. Maybe some class of data is for some specific group. Maybe some other data is related to some other specific group. Maybe some could be related to the males. The other sentiments could be related to the females, right? They are pertaining to different classes. So in that case, the classification report, this will be giving you the performance on each class, right? So this is again the important thing, right? Because you can understand if you are getting the classification report, then it's really important for you. So let us see. So if you print it like on each class, there are, precision, recall, F1 score. What are they? Let us see. What are they? So precision means proportion of true positives among all predicted positives. So the formula is true positive upon true positive plus false positive. This is the formula. Recall how it is calculated: true positive divided by true positive plus false negative. Proportion of true positives among all actual positives, right? F1 score, this is the harmonic mean. I hope you are understanding harmonic mean. You must have studied harmonic mean in your school days. Harmonic means, right? You can go and check it. What is the meaning of harmonic mean? Because arithmetic mean, geometric mean, and after that it came harmonic mean. So all these three things could have been could have been studied by you during your college or school days, right? So you can reopen your copies, notebooks if you have. Otherwise, you can go to the Google and you can find out what is the harmonic mean. And the last one is support. Support means number of instances in each class. How many instances are there in each class? So there are different classes, and for every class, like first class is zeroth class, which means sentiment zero, means neutral, and the other one is sentiment positive. So for the positive, what is the precision, and what is the recall, what is the F1 score, and what was the size of the data? Size of the data was bigger, 120, and for the zero, size of the data was small. The class data, this class means the zero class data, which means the negative sentiment, or you can say the neutral sentiment data, had 100 records, right? So support was for 100 records. So this is basically the classification performance. So in the first one, what was that? Accuracy score. You were not able to find out the classified report, but here you are able to find out the classified report. For each class, what is the performance of your model, that you can find out, right? This will help you to train your model more. So it's all mathematics. It's very simple statistical mathematics that you want to understand. So these are the columns that we have studied, and now comes the confusion matrix. This is the last one. What is the confusion matrix? A confusion matrix visualizes the model's predictions against actual labels. A confusion matrix is a table that helps evaluate the performance of a classification model. So basically, it is evaluating the performance of a classification model, right? You are classifying. Your model is a classification model because it is working on the different set of data, right? Some of them are positively classified, some of them are negatively classified. I mean, there are two kinds of sentiments: positive, negative, and the third one is your neutral sentiments, right? So this is the classification way, right? You are classifying the data. So how this how this model working on the classified data is performing, the performance, that performance is calculated through the confusion matrix, right? So confusion matrix, here is the example. You can see the 90 and 100 it has been given, and then 12 and 108, right? So what does this mean? You can see here. So class 0, for class 0, there will be two rows here, and there will be class 1, there will be 2 rows, right? So here you can see true positive means correctly predicted positive instances, false positive, incorrectly predicted positive instances. Then comes false negative, incorrectly predicted negative instances. Then comes true negatives, incorrectly predicted negative instances. Okay. So in that case, you can see like 90% and the false positives are 10 out of 100, right? There were 100 records. You can see on the top there were 100 records. If you see the sample size for this class 0 was 100, right? So among these 100, you can see that true positives were 90 and and false positives were 10, right? False positives were 10 and true positives were 90. And then for the class 1, which means for the positive sentiments, the false negatives were 12 and true negatives were 108, right? So that was done on the 120 records. Okay. So this is how the performance is evaluated. So you can see here, like it is fairly performing well, right? So this is, all about the uh, confusion matrix and what is the kind of insight these things provide to you. So precision and recall trade-off, class imbalance issues, and models strength and weaknesses, all these three things can be taken, can be inferred. I mean, you can take the inference from these results, like how your model is performing, what is the precision and recall trade-off, what is there any class imbalance issues, right? Are there any in class imbalance issues, and if your model is strong enough or the weak enough, right? So those kind of thing are described here with the help of these results. So these results you should use in your uh, you know machine learning models. You should have these things so that with every data that you are testing, that you are training your model, you can understand that how good it is performing, right? So with this, I would like to say have a nice day and bye bye. And please like, subscribe my channel. Please share this video with your friend if you find it useful, right? So with this, I would like to say have a nice day, have a good night, and bye bye.